This section of the course, we're going to do something really cool. This is a section of the class that's going to really, I think, open your eyes when you understand what we talk about here. The topic is rational exponents. So far in the class, we've dealt with exponents like x squared, x cubed, x to the fifth, x to the 10th, whatever. Okay? In this section, what I mean by rational exponent, what it means is we're going to have exponents that are fractions. So instead of x squared, we might have x to the 1/2. X to the 1/3, x to the 1/5, whatever. And I'm going to show you some really neat things that are going to really, I think, help you out. So let's just plow right in and see what we get. Okay, this section, by the way, is crucial. I mean, this section, the material we learn in this section is going to really go a long ways. The first thing I'm going to tell you is something rather generic, and then we're going to apply it to the problems. Okay? Anytime you see, this is just stuff you're going to have to memorize, okay? But it'll be easy to memorize, you'll see that. Every time you see something like x to the 1/2 power, which is a fraction, you might think, oh my goodness, what am I going to do with that? This I don't even know what to do with. Does it mean it's multiplied by itself? It's not multiplied by itself twice, so what could it possibly mean, okay? This is exactly the same thing as this. When we write this square root symbol, what we mean is, and I haven't told you up until now, we've solved a lot of problems like this, but I haven't mentioned it yet. What I mean by this is x raised to the 1/2 power, okay? If I have x to the 1/3, what that means is x, the cube root of x. And you can see the pattern here. If I've got x to the 1/5, let's say, that is the 5th root of x. Remember, this number up here represents the order of the root that we're talking about? This is exactly the same thing. In fact, it's really double arrows. Anytime I have this, I mean this. Anytime I write this, I mean this. Okay? And that is going to really get you a long, long way. Okay? So let's work a few problems, and we'll just go from there. You will get the hang of this by the time we finish working it. What if you have a problem that's like 81 to the 1/2 power? How would you work that? Well, once you remember that this is just a square root symbol, okay, then you do this just like before. Okay, 9 times 9 is 81. So I'm looking for a pair because this is a square root. Okay, here's my pair. So I pull the 9 out. This just equals 9. Simple. It's the same kind of problem that we were doing before. If you have 1/4 raised to the 1/2 power, again, this is a square root. Okay? So 1/4 is 1/2 times 1/2. 1/2, 1 times 1/2 gives me 1/4. It's a square root, even though I've written it this way. I'm looking for pairs, so I pull the 1/2 out. This just equals 1/2. Okay? Likewise, if I have 4/49, all to the 1/2 power. Again, I'm just taking the square root, and just to kind of break things up a little bit, if you recall back from how you deal with exponents, this is the same thing as 4 to the 1/2 up on top over 49 to the 1/2 on the bottom. Anytime you have an exponent applied to a fraction, you can apply the exponent to the top and to the bottom separately. That's exactly the same thing. On the top, we have a square root of 4, which what you should remember is just a 2, and by now we've done that so many times. On the bottom, we have the square root, written in this funky manner, of 49, which is 7, because 7 times 7 gives me 49. And that's the answer. Okay? What if you had something like 27 to the 1/3 power? Well, this is not a square root, okay? This is a cubed root, and it tells you right here, the 3 means cube root, okay? So, 27 is 9 times 3, okay? And 9 is 3 times 3. Because it's a cubed root, I'm looking for groups of 3, which I just found, so I pulled the 3 out, and that's just 3, just like that. So really, once you realize that, fractional exponents, like 1/2 is just basically the square root symbol, then you'll come a long way to doing these problems, because that's pretty much all we're going to do here. I will throw a few little goodies in here that will help you. Like what about 81 to the 3/2? Whoa, how would you do that, you might say? Well, you just break it up one step at a time. Let me show you how to work this out. First thing you need to recognize, I'm going to write it down and then explain it to you, and then we'll go from there. I'm going to say that this is equal to 81 to the 1/2 power, and all of that raised to the 3rd power. Okay? If you remember from beginning algebra in the previous course, when you have something raised to a power, and then that whole thing, again, raised to another power, all you do to get the final answer is you multiply the two exponents. You take the base, and the power that's going to be here is going to be these two things multiplied together. 3 times 1/2 is 3/2. So that's what I'm doing. I'm splitting this up into two things. The first is 81 to the 1/2, the entire thing raised to the 3rd power. I think you can see why I'm doing that, because this is just a square root now, since we've learned this little trick. The square root of 81, you should know by now, is 9, because 9 times 9 is 81. Now don't forget this is still cubed, because that's what we had to do. 9 cubed, if you run this in your calculator, comes out to 729. 9 times 9 times 9, so that's a number. That's it. If you were to, if you look at this, 3/2 is just equal to 1.5 in decimal. If you were to take 81 and raise it to the 1.5 power, on many calculators there's a button that looks something like this, x caret y. This means x, in this case 81, raised to the y power. So you can take 81 and raise it to the 1.5 power. The number that will come out will be 729, because that's exactly what we're doing here. What if you have 25 to the 3/2? Okay, that's just equal to, again, we're going to split it up, 25 to the 1/2, again raised to the 3rd power. Now inside, this is just a square root of 25, which is 5, again raised to the 3rd power. 5 times 5 is 25, times 5, again, because it was done 3 times, is 125. So that's the answer. Again, I broke it up here because I know that in this case, when I break up an exponent like this, what you do is you multiply the 3 times the 1/2, and that gives you what you started with. So that's why this is legal here. Let's say you had something like this, -8 raised to the 2/3. Okay. Now, I'm going to do this one a little bit different just to show you that it can be done. In these cases, I've put the square root, the 1/2 inside, and the top number outside. That works just fine. But let me show you this. I can also take -8, square it on the inside, and then raise the whole thing to the 1/3 power. Notice this is the same thing that we've been doing up here, because in the end, the exponent I started with is just equal to the product of these two exponents. 1/3 times 2, again, gives me 2/3. The order in which I do these exponents doesn't really matter. Okay, you can do either one in any order. You're going to get the same answer. For here, -8 times -8 is positive 64. Okay, don't forget this is raised to the 1/3 power. Okay, so in order to get the answer here, I need to do my tree. So let's start out with 8 times 8 gives me 64. And 8 is 2 times 4. 4 is 2 times 2. Again, 8 is 2 times 4. 4 is 2 times 2, like that. And it's a cubed root, so what I'm looking for is pairs of 3. And I found one here, and I found one here. So I've got 2 pairs of 3. So this is going to equal 2. I'm going to take this 2, I'm going to pull it out, times this 2 I'm going to pull out, which equals 4. 2 times 2 is 4. So it's the same thing. You just take your inside, you put whichever's convenient. I could have put the 1/3 in here and the 2 out here, and it just would have made things, you know, a little bit different, but you could have solved it that way just fine. In this case, I wanted to flip it to show you that you can do that. Okay. Now, let's move into something a little bit different. What if we have 6 raised to the 3/5 power times 6 raised to the 2/5 power? And we want to figure out what does this equal. Well, the first thing to remember is that anytime you have the same base and they have the exponents and you're multiplying them together, what you do, if you remember back from earlier algebra, is you just add the exponents. So this is going to be 3/5 plus 2/5, and this is all in the exponent of 6. And that's just a rule that if you haven't memorized, you're going to have to memorize. Same base, exponents, when they're multiplied, you just add them. Okay? 3/5 plus 2/5 is 3 plus 2 is 5, so 5/5. 5 over 5 is 1, so that's 6 to the 1 power, and of course, that's just equal to 6. So the answer is 6. You just add the exponents because we're multiplying. When you get these fractions, notice the denominators are the same, so I just add the top, and that just reduces to that. If you have, as a different example, 5 to the 2/3 times 5 to the 4/3, it's really the same story. You've got the same base, so I write it down. Add the exponents, so 2/3 plus 4/3. Again, I keep the base. The denominator here is the same, so I can keep that. 2 plus 4 is 6/3, okay, because that's just adding fractions. Of course, 6 divided by 3 is 2, so it's 5 squared. And 5 times 5, as you know, is 25. So that's the final answer. And what if you had 5 to the 2/7 all raised to the 7th power? Remember what I told you before, anytime you have something raised to a power and then the entire quantity raised to yet a different power, all you do is you keep the base the same and you multiply these exponents. This is the same thing we were doing earlier. So I'll have 7 times 2/7. Okay, 7 times 2/7. You can see the 7 is going to cancel with the 7 on the bottom because 7 over 7 is 1, so those go away. So what I'm left with is 5 squared. That's all that's left over because the 7's are gone, which again is just equal to 25. 5 times 5 gives you 25. Okay, if you have 8 to the 3/2 over 8 to the 1/2, how do you do that? Well, if you remember back from earlier algebra, anytime you have some base with an exponent divided by the same base with a different exponent, instead of adding them like you did in the case of when they were multiplied together, you added them. Here you just subtract them. So it's 8 to the 3/2 minus 8 to the 1/2. Okay? And if these rules of when you add them and when you subtract them seem totally foreign, then my previous disc covers all of that in great detail, and you can work lots of problems like that. Here we're focusing on the fact that they're fractional. So actually it needs to be written like that: 3/2 minus 1/2 in the exponent. So what you're going to have is 8, and since the denominator is the same, you've got 3 minus 1 is 2 over 2, because the denominator stays the same, 2, which is 8 to the 1st power, which is just simply 8. Okay, now we're going to move into problems a little bit different. If you have 2 to the 1/2 times 3 to the 1/2, and that's all, again, raised to the 2nd power, how would you handle that? Now remember, we're building here. At first I have simple and we get more and more complicated, okay? So when you have two things inside and you have an exponent, remember what I told you before, what you end up doing is distributing that exponent kind of in to these exponents here. So what you will have is 2, okay? This gets multiplied by this because it's an exponent raised to an exponent. So that's 2 times 1/2. Again, that's multiplied by this one, which is 3, and then 2 times 1/2. All I did is, it's the same rule. Exponent raised to an exponent means you multiply them. The only thing is I'm doing it twice because there's two things in here, and so I have to do it twice here and there. The end result's going to be multiplied together. Okay? For this one, the 2 cancels with the 2 because 2 divided by 2 is 1. So I'm going to have 2 to the first power. I'm just going to leave 2 here. Here, same thing. 2 cancels with 2. So I'm going to have 3 to the first power, which is just 3. And so that's just equal to 6. So up until now, what I've really taught you is two things. The first thing is, anytime you have a fraction in an exponent, like a 1/2 or 1/5 or something like that, what it really is a radical of some kind. A square root, a cube root, etc. That's what I've taught you. That's the first thing. Very important. Remember that. The second thing that I've taught you is that when you have a even more complicated fraction in the exponent, like 2/3 or 3/5, you can split that up into two parts. The first part you can take, like if it's 2/3, you can have 1/3, and then you can raise the whole thing to the second power, and because that's equal, you can break it up into two operators that way and solve the problem. Okay. The third part of this lesson is equally important, and this is going to save your bacon on many, many occasions to simplify problems. So let's go ahead and show you what I mean here. The big thing I'm going to show you kind of in general before we get into detail is the following. Anytime you have some number, whatever it is, to the negative, I'm going to make up a number here, -2 power, for instance. Okay? That is the exact same thing as saying 1 over, and then it's the same exponent in the bottom. This is equivalent. So I was giving you an example before with if it's fractional, it's equal to a radical, and just memorize that. This is the same thing. Anytime I have 1 over like x squared or x cubed or whatever, I can always write it as a negative exponent. If I have x to the -3, that's just going to be equal 1 over x to the third. X to the -64 is just equal to 1 over x to the 64. It's very simple. Anytime you see a negative, you just stick it on the bottom and take the negative away from it. These are exactly equal. If you were to go to a calculator, you could very, very simply prove that to yourself. So let's work some problems to kind of build on that. 4 to the -1/2. Now we're going to combine a few things here. I just told you that that's equal to 1 over 4 to the 1/2. But I also told you that 1/2 means, what does it mean? Square root. So the square root of 4 is 2. So that's what stays on the bottom. That's the answer. If you have 27 to the -2/3, like this, again, your first reflex should be, well, that's fine. Let me put it on the bottom, 27 to the 2/3. Okay? But I also told you from the last section that I can rewrite this as 27 to the 1/3 all raised to the second power. You see how that goes? Because 2 times 1/3, because it's an exponent raised to an exponent, 2 times 1/3 gives me 2/3, so I can split it up like this. Okay? The cubed root of 27, you will convince yourself, 9 times 3 is 27, 3 times 3 is 9. I'm looking for groups of 3, so the bottom line is the cubed root of 27 is 3, but it's still squared, so I've got to carry that through. So this quantity is 3, and then I'm squaring that, so I've carried it there. 3 times 3 is 9, so that's the answer. Okay? And what if you had, now this is going to be cool, you're going to like this, 1/2 all raised to the second power. Now, in the previous section of this class, I taught you that when you're solving an equation, if you have the square root of x, to get rid of this square root, the way you do it is by squaring the thing. And I told you that the square and the square root kind of cancel, and so what you'll be left with is x. I told you that, and I just told you to believe me. Now I'm going to show you why that's true. Because the square root of x is a fractional exponent like this, this is the same problem as what I had showed you before. These two things are exactly the same because this is equal to this. Okay? When I do this, this is an exponent raised to an exponent. So what do? I multiply the exponents. So this is x, 2 times 1/2. I multiply these exponents. 2 times 1/2 is just 1. So this is x to the 1. So this is x. This is why the square root is the opposite of a square. And the square is the opposite of a square root. When I say opposite, what I mean is when you apply it to the other thing, it just kind of goes away. The reason it goes away is because the exponent goes to 1 when you do this, and you're left with what you had to begin with, which is exactly what you want to do here when you're solving equations. And that's why that's equal to x. So really, for the short term, just memorize it. And that'll make a lot of sense. But I just wanted to kind of give an opportunity to tell you why that's the case. What if you had something a little bit more complicated, like x to the 1/7 times x to the 3/7, all divided by x to the 2/7? This will use kind of a few different things that we've talked about. Let's work on the top first. Here I've got the same base, and I've got exponents, and they're multiplied, so I'm going to add these exponents. 1/7 plus 3/7. On the bottom, I'm not going to touch it yet. I'm going to work with it in just a minute. Okay? 1/7 plus 3/7 is 4/7. 1 plus 3 is 4. 7 on the bottom denominator, it stays the same. This is 2/7 out here, like that. Now I've got the same base on the top and the bottom, and they have different exponents, so I can subtract those exponents instead of adding them like we did here. So that's x to the, and you always start with the top and subtract the bottom one. 4/7 minus 2/7. Since I've got the same denominator, I just subtract the tops. 4 minus 2 is 2, and of course it stays over 7. So this is the answer here. And we'll do one final problem to kind of solidify all this stuff, and it'll kind of be our little bonus problem to kind of get your muscles flexing. If you have y to the 5/6 times y to the 7/6 over y to the 1/3 times y, and you take this entire thing and raise it to the 3rd power. Now would be a good time to pause the video if you want to see if you can solve that on your own. Okay? But what you really want to do is take it very methodically, and so that's what we're going to do. On the top, I've got the same base, okay, and different exponents, so I can add those because these are multiplied together. So, in the top, I will have y raised to the 5/6 plus 7/6. The bottom is the same, so all I do is add the tops. 7 plus 5 is 12. That's 12/6. You see, all I did was I reduced this. 5 plus 7 is 12 over 6. So I've got that. Okay, on the bottom, I've still got my y to the 1/3 times y, and don't forget I've still got this whole thing cubed. Okay. Now don't forget, on the top, 12 divided by 6 is 2, so this is y squared. On the bottom, this is 1/3 times y, and this whole thing, again, is cubed. Okay? Now here I've got a y squared and a y. Okay? And I've got the same base, okay, and I've got different exponents, so I can just subtract those two. So I can say on the top it's going to be y to the exponent of 2 minus 1, 2 minus 1 over y to the 1/3. Okay, so that's going to be y, 2 minus 1 is 1, so I'm left with y over y to the 1/3. And don't forget, this quantity, again, was cubed, and this quantity, again, was cubed. Okay, so now I'm going to apply this exponent to both top and bottom, which I can do. So on the top, I'm going to have y cubed. On the bottom, I'm going to have, it's an exponent raised to an exponent, so I'm going to have y to the 3 times 1/3. 3 times 1/3. Here it was just 3 times 1, so I'm just left with that. Of course, 3 divided by 3 cancels because that's just 1. So I'm going to have y to the 3rd over y. And again, I've got the same base, different exponent, so I subtract these guys. 3 minus 1 is just 2. So I'm left with y squared. So let's just take a step back and look at it. I had this, I reduced this. 5 plus 7 is 12 over 6. I've got this. I didn't do anything different. 12 divided by 6 is 2, so that's what I did here. In order to get from this step to this step, I noticed I had the same base, okay, and different exponents, so I just subtracted 2 minus 1, gives me this right here. Alternatively, I could have just said, okay, well, I've got a y square here and a y here. I can strike that, just put a 1 there, which is really the same thing. 2 minus 1 gives me 1. Okay, so I have y to the first power over y to the 1/3, and that's all to the third power. Here I chose to go ahead and apply the exponent to the top, gives me y to the 3rd. To the bottom, I multiply these exponents here. Of course, when I multiply them, they go away, so it's y to the first power. And then to finally get it, you just subtract these exponents because this is division. 3 minus 1 gives you 2. And that concludes the lesson on rational exponents.